So the approach to the chapter that I took was thinking about what was the primer that I wish I had had stepping into my role.
Yeah.
And so that is encompassing. It definitely has probably a bunch of gaps. I think if I've touched networking at all, it was very barely. So there's so much more to security than what is here. And the idea I had when I was writing the chapter is what would get people started down the correct paths and helping them to know what to look for. So that was the approach that I took.
Yeah. I think yeah, having this chapter only just to start building your platform security would be an amazing start. So yeah, that definitely shows that the approach by the way this chapter was written, I reckon. So I think it's starting with reconciling security to the left and zero trust ideas, right? And then yeah, looking at the details one by one. So yeah, do you want to give just a very quick explanation of what this means for you and like how this can be improved every day?
Well, I think Max said it really well in one of the earlier sessions, right? That when you push things to the left, you're not actually moving the work; you're just adding responsibility scope for and shared domains of responsibility, really. And so that I didn't put it so succinctly here, but what I was trying to kind of say was that it's there needs to be a culture of security, I guess. Like everybody needs to be aware of it. Everybody needs to be concerned with it. And so if you should be pushing it to the left because everybody should be doing things in a secure way. But there's kind of the responsibility of the platform to help with the enforcement, because it is the central thing where all of the pieces meet. So that's really kind of like high level. I think the takeaway I wanted people to have, and maybe I said it differently in the book. I did write it a year ago, so who knows what I said in there.
No, it's okay. I guess this traditionally was owned by some specific security teams and just was trying to be enforced by them, and nobody actually wanted to participate or try to be part of it unless there was an issue. So it was more like a reactive approach, which I guess to the left and zero trust kind of brought it to the center of the whole platform setup, I believe.
Yeah, because there's, I think, a bit of a natural friction between those two things, right? If you have zero trust, then just because they're doing security on the left doesn't mean that you can really even trust but verify, right? I think I talked about that. Like these are all kind of a little bit in conflict. So there's things that the platform can do to help enforce everything, policy engines and so forth, to make sure that security is happening on the left. And that's where the work is being done, or a lot of work is being done, not all of it, obviously, while not leaving room for people to consider pieces as optional. I think that was what I have seen, is that there was all these like secure ways to do stuff, but they were not easy or mandated, so people wouldn't do them.
Yeah. And do you I don't know, what are the maybe biggest pitfalls you've seen in this shift of implementing security checks earlier rather than having them somewhere else or like owned by a different team?
So I think that the risk, I don't want to call it a pitfall, but the risk of having all the security checks earlier is that if you check things at build and commit and compile time and you fail to think about them at runtime, a lot of times the developer teams have no hand in the running of their software, right? You get an SRE team for that, a DevOps team or whatever. Like they're not really involved with the production environment, nor should they be, because there's usually privileged information and so on and so forth there. So the developers will lack awareness of what's happening on the ongoing basis. So you can risk a feedback loop gap for them to understand if there's an issue, either a security issue like a CVE or an unintentional security issue or an unintentional maybe a compliance miss even, that might get because requirements change or, if new security issues are found or so on and so forth. And so if it doesn't get, if it's a part of the code base, for example, that doesn't change very often, or if it's a database configuration that has never changed, right? It's not going to you're not going to see it during the development lifecycle the same way. So you need that runtime visibility and that runtime insights into the health of the software and its security and its compliance. And so by pushing it, the risk of push left and trust but verify is that second half of things, which is now everything is up and running, gets completely forgotten because developers tend to not have the same awareness as operations people on these topics. So that is, I think, a problem that Zero Trust solves by bringing things into kind of okay, there's a domain of ownership here, and that domain may be shared, but it's all encompassing.
Yeah.
So that I think is really the risk of pushing things left is assuming that the whole life cycle is covered by doing that, and it's really not. It's really just helping to find some pieces as early as possible, but you don't know what the unknown unknowns are.
Yeah, I definitely can see that still communication gap happening between two ends of this whole life cycle. Like still, I think we are learning and improving things, even though there are new ways and practices are coming every day. Yeah, and I think in the next section we are going to talk about the requirements of a good secure platform, right? Like what's a good platform security should have an at minimum, like what are the minimum required controls. So it starts with the design phase starts with scope security, which is always good. And I couldn't find where I saw this afterwards. There was this mention of security theater, which was really interesting. And I would really like to ask, like, if you could elaborate on this a little bit.
I'm not sure the context that I mentioned it. That sounds like a thing I say. The context that I mentioned it
I
in
think
the book.
over engineering was the idea there, like rather than designing the minimum requirements, pushing it over the line too much that it just is not. It creates a friction between development and, I guess, security.
Yeah. So. Yeah, the caution I put out was that if you go for the maximum possible levels of security out the gate, you're going to basically create too high a barrier of entry to the utilization of the platform. So just like with everything, of course, things should be iterative. And so the other part is, I think that, I don't know if I put it this way in the book, the risk that you have when you say, if you fail to scope security, is that you may not implement the things in the correct timing and order. So if you fail to scope your security or your compliance, which are related but different, then you may not necessarily work on the aspects of it that are the most important. So an example of this is you can do 5 million things to secure your data, but if you haven't validated to make sure you're at, that's kind of amiss because you fail to just the very first step is reduce your surface area for risk by only storing the data you absolutely need to store, and have a life cycling and know how long you must store it for or how long you should store it for. Like, it's one of those things where it's fail, and then if you have all this data you need to have, you artificially created a surface area of risk that you didn't need. So by make sure that you're not just implementing the right things, but in the right timing and in the right order and on the right pieces, right? If you don't have certain surface areas for risk, if somehow you are surviving without a database, I don't know, then security compliance stuff would not make sense. I literally cannot have a database. I just also couldn't come up with a better example off the top of my head. So
Yeah.
is just but the hypothetical I think stands up, which solve it.
Okay, cool. Yeah, I think it's just great to scope it with the minimum requirements and just try to not over engineer. Yeah, I would really like to hear if there are red flags in for identifying security theater, but let's move on to the next one. The addressing OWASP 10. This is a really good section to give some guidance for the folks who are only starting, I guess, because if you of course it's not sharing. Yeah, if you check out the link at owasp.org, you will be able to see a list that gets updated with the top 10 focusing areas for cybersecurity, and these are like great for guidance and to start with if you're only thinking about them just now. And then they also released a Kubernetes version of this list, and I guess 2022, and you can find it, I think, in OWASP/Kubernetes. I'm gonna have to maybe switch to this one. Here. Yeah, here you will be able to see under the projects, you will be able to see the top 10. And I guess this is the latest, right? 2024, 2021. And then if you can, I keep searching it here for some reason.
Yeah, I had to make sure to carefully date everything I put on from them because I was like, it would just absolutely happen that we would finish this, we would publish this, and like a week later they would put a new one out. Yeah, it seems like that hasn't been the case, but that was my very real fear when referencing these standards. That it would become quickly outdated.
That's something that's like a paranoia I would definitely have if I ended up writing a book at some point. Like, my references, how do I make sure everything is dated?
There's actually later in the chapter I referenced an open source project, and one of the technical reviewers were like, hey, this open source project is really old, and I was like, it's just about the pattern, not about the specific code, and it's a good pattern even though it's dated. So I'm going to leave it, but I did know at the time that it was a dated reference, and of course it was caught immediately, but I stand by the pattern that they used, and therefore it was worth the reference.
Yeah, absolutely. So do you think these lists should be a full checklist or like a baseline?
These are the baselines for sure. What they found is what they did an assessment and determined that like these were the 10 areas that where things were going wrong the most often.
Yeah.
So like it's just a good baseline. I think picking your floor is pretty well industry standard. Picking your ceiling, I think, is very subjective.
Yeah.
And so I would say this is the floor. It's a good floor, builds a really solid foundation. but it is the floor. And I think that they don't talk about one of the things that I talk about, which is, of course, auditing. What are we even keeping in terms of data, right? Reducing your surface area for risk by only storing the right things and then storing that securely.
Yeah.
I cannot like emphasize that enough, that we do not need to store absolutely all of the data everywhere, always.
When I was a developer once, I had this obsession of just making sure data is like everywhere, duplicated, or like this version is there and the other version, maybe we could keep it there as well. This was obviously before all this data tools were there, like data lakes and everything. So you just really needed them in different versions, but because it was really expensive to calculate them on the fly. But now looking at this, I'm like, okay, what were you thinking? Obviously, we didn't have all this very detailed practices back then. Also, the regulations were not that clear, I guess, back in the day when, in the ancient times.
In the ancient times when databases had passwords stored in plain text.
Yeah. Yeah, I think that was when I started my career. And then afterwards, when we actually define the scope, we can move on to implementing threat modeling. And so threat modeling helps teams collaboratively answer, I guess, some questions here. What are we working on? What can go wrong? What are we going to do about it? Did we do a good enough job? It looks like a continuous improvement model to me, but just please go ahead.
No, I pulled this very directly from the reference that I listed there, threatmodelingmanifesto.org. And in a way, it looks also the same as the decision tree for build versus buy, right? Or you said a retro after a release on the software development lifecycle. It's really, again, we have really good patterns for doing these things. We just need to remember to apply our good patterns in the right places. So the same things that we do for releasing a feature, we should do for security. We should do for decisions on, are we, buying a technology or building a technology, adopting an open source technology, which I just kind of would classify under buy for ease of communication. We really just know how to ask the right questions. We just need to ask them in the right places.
Yeah, I think that's a great example here. Like we are working on the way users authenticate to the IDP. Then what can go wrong with overly permissive RBAC configurations? Then work through each of these with top 10 items in the Kubernetes list. I think it gives you a really clear way to design your threat modeling. And then you are touching common security standards and frameworks, which sometimes feels like a letter mumbo jumbo to me. And you're like, which one was which? You have to just sometimes take a step back and try to remember when you see them in like someone's CV, like certifications.
I literally call it demystifying the language of acronyms.
Yeah.
Which, in retrospect, I'm really proud of myself for putting it that way. Like, good job past me. That was a clever turn of phrase.
Yeah, that caught my attention as well. Well done.
And this is still, again, not all encompassing. I just kind of grabbed the ones that I hear about the most. There are so many additional standards for frameworks. And again, I just trying, the table could have taken up 3 pages if I tried to do all of them. So getting people thinking about these items, helping direct people to know where to go to look for the information was a big, was really what I was trying to just accomplish by laying some of them out. And I also just kind of thought it was interesting to talk about where the standards came from in that table, right? Mm-hmm. Like PCI DSS coming from credit card brands themselves, right? This was the banking companies that created the security standard not a government body. A lot of them come from government bodies right now, but that one came from private industry. I thought that was really interesting.
Yeah. Also, if you have to use them, like how do you support multiple overlapping standards, right? That's a very sometimes hard like job to pull for companies if a new standard, if a new regulation is going to be applied in a few years' time, and you have to plan accordingly. You also need support, I guess, from different sides of the organization to actually unpick what this means for your company when you're designing around some of these regulations and frameworks.
Hillary, question.
Yeah.
So I didn't see SOC 2 in your list, and SOC 2 is I've had lots of attention on lately. Is SOC 2 on a different list?
No, I just didn't reference it, and
Okay,
part
Let's
of it
have a look.
was the table was getting really big,
No,
and
no,
I
no, it's
didn't
okay.
want
It's
the
okay.
entire thing to be a table.
It's at the risk of me exposing my ignorance. There's so many different categories of lists. I didn't know if it fell under this list or not. So okay, thank you.
Yeah, no, it was again, it's so much. It's such a big thing, security, and they said there was a fun fact into like the publishing like world. There's a page cap on chapters and a page cap on the book. And so this chapter was supposed to be around 30 pages. And my outline for this chapter was 17 pages. So I started having to make at certain points what felt like arbitrary decisions on what to keep and what to cut based on whether or not I felt like maybe we got the point.
I bring it up because a colleague of mine went to Utah, to the QCon in Utah, just so he could better be SOC 2 compliant for his clusters that he's managing at his work. So someone thought SOC 2 and Kubernetes were linked together.
Yeah, can someone share a link maybe in the chat? Because I think when I typed it, I found so many different,
That's okay. Yes, of course. But for me, just
industries just using the same thing. I don't think I got to it.
Okay.
Yeah.
All right. Thank you.
If I can. Oh, I think I found it. No, I don't think that's it. Okay, if I can manage to find, I'm going to drop a list. It's in the notes, so maybe it's important for other folks to check out afterwards. But yeah, there are so many of them. I guess you might need a booklet, a gift if someone happens to purchase the book. Oh, here's the security frameworks you might be interested in. And then I'm gonna, just to be mindful of the time, I'm gonna move on to asset protection, which I guess your data is your biggest asset. That just explains the whole chapter, I guess, the section, that we understand different states of the data and how you should secure your data in those states, right?
Yep.
So securing data at rest, which is the time that your data will spend the majority of its time. And we have a securing data in motion, and you have to be mindful of, obviously, how you expose your data, how you share your data with different services, and mindful of. Oh, thank you, Jack, by the way, for. Oh, SOC 2. I definitely misspelled it.
Thank Copilot.
And then data in use, how you can secure your network, and how you can secure your data when you change it, and then it's basically like the data retrieval and data cache, the things you have to be mindful of. And then you go secure your network, right? For Kubernetes, this means picking a CNI tool and having observability and designing your networking in a secure way. So you've touched different CNI tools, one being Cilium here, and then I had this question in mind, like how to audit or validate network policies that are actually enforcing these boundaries.
Yeah, it's there. Oh God, I hate networking so much. Like I said, networking is just such a hand wave here. Not my strong subject. So for some of the compliance frameworks that I referenced, an important thing that you have to do, like for PCIs, you actually have to document your network topology and policies. You can do something. So obviously you have the tools provide some ability to do this. You can do like network like you can do some level network policies as code. It's basically as code. And so because it's declarative, because it's as code, that's sort of the easiest way to design your however you want to audit it. Either it's like a human, there will be a human element to it. You can also do automation around it. You could have, CI jobs that validate certain things are true, or parse the policies and make sure that it's conforming to certain standards. Or there's ways of approaching this that starts getting, if I tried to iterate over it at large, one, I would be super out of my depth. I'm not a networking expert. Don't trust me with that stuff. And two, it would have been its own book. And so I think the one thing I didn't find during this was more like there were some, if I'd found like a book that I had read that I could really recommend, or additional references that I could really stand behind to link in, I would have put them in. Just due to the time constraints that were happening between the publishing and personal stuff, I didn't have time to go through and read a book that I could definitively recommend as being a great authority on the subject. So a hand wave at it, hoping to get everybody started on the right path, looking at the right tools so that they can design the right things.
I completely understand. It's also a very, like, as you're saying, it's a different book, like its own book. I would like to move on to the secret and token management that we face a lot in Kubernetes, this problem. Do you want to maybe talk about this and strategies? Maybe, for example, we can even talk about the bootstrapping problem of the IDP, right? How do you get the first ever secret into the IDP to actually build your IDP?
Oh yeah. I just, to a certain extent, you can't avoid having secrets on a cluster. They're going to be there. I don't think I talk about it. I wish I had. The most important thing is to lay things down with the appropriate RBAC. So something I see, and I don't, in the year 2025, I wish I could say I never saw this, is we have teams that are all logging in with kubeadmin instead of named RBAC with the appropriate levels of restrictions. This still happens. And that needs to not happen, really. You can put in the sidecar model, what like's drawn out there. You can use something like the external secrets operator so that you store references to secrets. And then those get pulled in by the operator. And then when you need to rotate the secret, it automatically updates it. And so, that's there's patterns for this that are good. But you can't, none of that completely usurps the importance of everybody accessing the platform with correct RBAC.
Right.
And I talk about correct RBAC in a lot of places in the book, so I really didn't harp on it again here. But eventually there are people you are just going to have to be, people and software service accounts and stuff that are going to just have to be trusted to be able to read these things. Those should be few and far between.
Yeah. And you are talking about external secrets operator, which is a very I think popular and quite strong open source project right now in terms of managing secrets in your clusters, which I used to work for the company who was behind external secrets operator. So maintainers were my colleagues, which I'm very proud to share. And they have this very fundamental problem of, having secrets in clusters. What does it look like? Like, how can we have this single source of truth for our secrets externally somewhere else? And how do we rotate all this?
Yeah, they did great work with this. This is something that we recommend all the time at Red Hat. I know I personally have recommended it to people as well. You're never going to completely get rid of the ability for some folks to have access to some things. But again, it's all about reducing that surface area for risk. And this allowing you to be able to very quickly rotate a secret if there is an exposure is hugely powerful.
Yeah. And then
so Hillary question. So in this context, does this cover the cases where our products are set up with service meshes where everything's interconnected with MTLS and everything has to be, and all the keys are being rotated all the time? Is that sort of underneath this umbrella, or is it separate from that? Because I think the service mesh problem is its own bowl of spaghetti.
I do think, I think you're right. The service mesh problems is its own bowl of spaghetti. So what the external secrets operator really does is if you have a secret, let's just say that you have your secret for pushing your logs from your cluster to like a centralized Loki service, for example, and that requires a secret. Then in that secret, let's say you rotate it every 90 days. So what that allows you to do is just replace the secret in your password manager, whether that's Vault or like 1Password or Bitwarden, whatever it is. It allows you to just change the password there, and then the operator detects when there's a change, and then it will replace the secret on the cluster and so you can have if you needed to have the same certificate in multiple places for some reason, then multiple instances of the external secret operator across various clusters would all pull down the same certificate. And ideally that wouldn't be the case, but I guess it can happen. But so basically it just will change though it's on the cluster for you without you needing to go log into all of your clusters and update all your secrets.
Right.
And so that does the thing. Keeping in mind that things are stateful, so or not stateful, the opposites. Things are stateless, but still, once the containers are running, they're using the secret, so it doesn't restart like the other workload containers. So there's other things there where they need to pick up secret changes or so forth. But by looking at a reference versus the actual value, they should continue to function correctly without needing that restart.
Okay.
Yeah.
Okay.
Do you think there are some risks? It's not a security risk, by the way, I'm referring to, but like, do you think there are some difficulties in the sidecar model that at scale that might bring some problems, like for example, it's a very common way, right?
Yeah, so the
But
sidecar model
imagine
is
all your workloads have a sidecar just to be able to get that secret. And imagine at scale the number of sidecars the resources ideally shouldn't be that much these sidecars are consuming, but
it's so there's an interesting thing that I've seen a couple times that you could increase the risk for adding a thing always adds a level of overhead for the thing. And so one thing that I have seen happen rarely, but does happen, is I have seen TCP socket exhaustion a few times on Kubernetes clusters.
Yeah.
So by just having more items, you do have that. And also you can eventually fill up your key spaces in etcd. So even if they're not using a ton of resources, you can actually potentially like just overfill the key spaces on etcd by having too many things. Or you can actually just fill up the actual like storage of etcd by having too many things. So there's an extent to which, okay, the networking layer has caps limitations. So if you undersize your cluster for the number of pods and sidecars and everything you have, you could start seeing problems in your networking stack. It wouldn't be the sidecars specifically that do that, but they would certainly aggravate any such issues. And then if you start having just a bunch of stuff, you can start potentially overfilling etcd. But the bar for that, again, you have to be doing quite a few things wrong in addition to using sidecars for that to really happen. I've seen it happen when mostly from folks who are using one giant cluster to do all the things. So they've got their dev, their test, their staging, their load testing, their stress testing, and their production all on the same cluster. And then again, sometimes they do that and they don't even have node selectors in place to at least have some level of isolation, which one of the earlier chapters is I recommend against doing all of these things, because you have to be worried about your shared resources. So
yeah,
any additional container does utilize the things that are shared wholly across the cluster, such as memory, such as CPU, such as networking. But realistically, by themselves, they're not going to introduce a problem or instability. It's more so that it's just not the best model when you rotate secrets frequently.
Okay. So this sanitizing logs is a short one, but I think it can be soft chapter as well, because I think, again, historically between software developers, I mean, product owners and platform owners have always, I think, had clashed about the ownership of the logs and like how do you store the logs, or like who owns the logs, or who owns what's in the logs, has been, I think, a long problem I've seen so far. And obviously, if you have a leak, this it makes it really hard to, I guess, address. I wanted to ask if you've seen any, I don't know, data pipelines to have very sanitized, clean logs anywhere, apart from just SonarQube or anything else.
No, nothing else so specific. It really does have to be written into the application code. I actually had to go make a code change a couple months ago. Because, and this was one of those things where the person who wrote the logging didn't know the behavior of the API that we were logging against. And the behavior of the API that we were logging against was that it was a REST API. And for the key went into the URL string instead of in as a token because of the age of the API. And so
I think that's a common one. If you
it's a common issue. A lot of newer APIs use the bearer tokens for gets and posts or anything, right? Yeah. But this one, being older, actually had the key in the query string, and so whoever wrote the logging, I think, didn't know that, and so we were accidentally logging a key. And so there's just a little update from me where I just change where we only are logging the endpoint. It was like a 5-character security fix. I added .hosts to what we were logging to reduce the scope of the item in the struct. And I was like, oh yeah, look at me go, 5 characters. So much code generation.
Cool.
It was so minor,
I think it's a really common one though. Like
but so it does have a lot of it gets done at the application level, where for what we decide to log is really where you need to actually do that sanitization and understand that. So
Yeah.
If you're surfacing an error, making sure that you know surface the error only as much as you need. You do not need to have identifying information in it, or you do not need to have passwords in it. Most of the time, that's fine. One technique that I saw used at a company I used to work for was we passed into our logging a thread identifier, so that if we needed to do any tracing of things, we could follow the logs for that whole thread and figure out what it was doing and where it was going and if it gotten stuck or what have you. And so by helping us to identify like the data, like well, I mean, we knew the data paths, but like which thread was following the data path, that helped us to find bugs without needing to expose like more information about the issue. It allowed us to do tracing and so forth and it was a non-distributed system, but it allowed us to do this tracing and so forth a little bit more efficiently. So there are things you can add to your logs to augment in order to compensate for what you need to remove. Then that can all help, but it really has to happen at that application layer. The application needs to make sure that it's logging only what's appropriate.
Yeah, I think also in terms of PII type of information, there are some anonymizer tools that developers can put their logs against, and then the amount of information stored will be fully anonymized, but you still will be able to see what you actually logged into the central logs or distributed logs, whatever you have.
Yeah, and I'm certain there's all kinds of amazing libraries that I'm not aware of off the top of my head for this.
Yeah. I'm gonna quickly take a look at the SBOM practices because we didn't get too far, I'm afraid, in this chapter because it was it's such a dense one, and we still have, I don't know, like more than half of it. But for the SBOM practices, do you want to, I don't know, explain some approaches to how to integrate in these into developer workflows, and like how to train your developers what this actually, the value of this, right?
Yeah, I think for me the lowest barrier to entry on it is just having it in like either a GitHub workflow or like just the first, like one of the first steps of your CI jobs.
Yeah.
And if everybody's using the platform, then the CI jobs should be pretty uniform. So you kind of have that guarantee. And so I think when we think about security needing to be a culture, right? And a shared domain of ownership, this is the socio-technical aspect. I don't think a lot of people would find it unusual or shocking to be told that, hey, we need to have a software bill of materials and understand what we have and validate, that there's no CVEs against it and all these other things. I think what is a natural follow-on to having an SBOM is starting to really like evaluate what is in there. So I think a hard question to ask is sometimes we pull in a library that we find because it solves our exact problem. But was pulling in this library the right decision? Either not just from a security and compliance standpoint, although those are very topical, obviously, for this chapter, but also from a sustainability standpoint. What happens if the person who created that library or that module decides to stop doing it? They quit software engineering and become a goose farmer or a mushroom farmer, whatever the dream is today. Right? Where do we go from here? What does that mean for us? So I think that the importance of having an SBOM and the ability to enforce the creation of one in the tooling is very low level. I think what the natural questions that need to start coming after you have that bill of materials, those are going to be probably the harder challenges about making sure that we're secure, we're compliant, we have sustainable technical debt. The platform team can't answer that last one for the software application engineering teams, right? They have to answer the sustainability of the technical debt for themselves. But the platform is definitely the central location where we can answer the security and compliance posture questions.
Yeah. Also, I guess having visibility as a starting point is, I think, is the best thing you can do if you're taking, approaching this problem in iterations. So that's like, okay, as soon as you have all this in your pipelines, you'll definitely have great visibility in your software materials, and I think that's when you start thinking out how to prepare for the future, if that it be a CVE or a package not being actually supported anymore. Obviously, there are different formats for these and different tools, how you can also different practices to integrate this with the pipelines you have, right? And then I think maybe just we can close this session with understanding pipeline security. Obviously, there are, I guess, very mature practices already, but when you talk about GitOps, yeah, it might be a different challenge, right?
Yeah, and this is very minor covering of GitOps because we went over it so in depth in chapter 5. Obviously, it's also can be its own book, and there are many own books for GitOps. So I would defer to some of those. Well, I would say high level, we talk about the push versus pull model and the inherent benefits and risks to that. Like a pull model is more secure because you know that where you're going.
Yeah.
If you're accepting pushes, that can be somebody or something impersonating the authenticated or usually authenticated system that does the pushes. So obviously pull model, more secure. You're going to have to decide what's right for your organization. And then when your GitOps system is acting, obviously having it have the correct RBAC via service accounts. And I think I don't remember, somewhere else we discussed service accounts in the book.
Yeah.
Use a service account where it's appropriate, and GitOps is where it's appropriate.
I think it was somewhere, I forgot, somewhere here. Yeah, my O'Reilly also decided not to show my previous bookmarks, which is really annoying. All right, and then so you also discuss what the financial one Acme would do in their security journey. Our fictional company. And so this chapter, I think, is closing with this one. And yeah, I think that's a really long, dense, and great chapter. Thank you for this and for the session. Folks, do you have any questions for Hillary before we just sign off today?
Thank you.
Thank you for taking care of my questions. Thank you.
Thank you for sharing links, folks. I will try to put them on the notes before we sign off today.
And then there must be some sort of a meme thing about mushroom farming. Is it Hillary? Why did you bring that up?
Oh,
maybe she's dreaming of it. I don't know.